Hello, everybody. Morning. How's everybody? Excited to be here. Today, I will be talking about progressive web apps and whether I consider them to hold the keys to our future. First, a little bit about me. As Marco already introduced me, my name is Vedrana Tozija. I am a software engineer. I am a part of Adivas. Thank you. I am part of Adiva's global developers network, and we are based in Skopje, Macedonia. As part of this network, I have had the privilege to work on a variety of projects of different sizes. And I've come to a conclusion that not only as an end user, but as a developer as well, I think we can agree that the dinosaur is one of the most hated sites on the internet. I mean, if you're not able to connect to the internet, how is everybody gonna know what you had for lunch? It's a nightmare. But many governments and companies are doing great efforts in trying to make that site happen less and less. Many steps have been taken by the IT community to ensure that this number, the world average internet penetration rate, be above 55%, which as of June 2018, it has been pretty low, world average. Some continents is better, some is worse, but generally speaking, this number is not okay. I believe this is because cell phone plans and cell phones themselves still are, in many countries, very expensive based to income and not easily accessible to everyone. But even though this is a problem software developers can't fix, there is something that software developers can do, because even though of the web's initial very visionary idea and design, it could not take into assortment the amount of different devices that everybody would have at their disposal today. So what can we as software developers do? Simple solution would be to switch to offline first solutions. What would this entail? Users should be able to see their data, whether the device is online or offline. Whether they're online or offline, they should be able to edit their data, and they should be able to access it from different devices. So, this is where progressive web apps come into the picture. What are progressive web apps? According to Google's definition, a progressive web app uses modern web capabilities to deliver an app-like user experience, which is a very nice way of saying it's a mobile website that becomes an app. Its main characteristics are: it works over a secure channel, it has the ability for web push notifications, it can work offline, and it can prompt an add to home screen. How do they work? I'll go over the main technical components of the progressive web apps. First is the web app manifest. Second are the service workers. Third are push notifications. Fourth is the application shell structure. Let's get into them one by one a little. First is the web app manifest. It's a JSON file that is basically a config file for your app. This is the first component that gives the progressive its native app interface experience. And here, the developer can store everything that is configurable for their app. If you want it to be full screen mode, if you want the URL bar to be shown or not, name, description, everything that is configurable goes in here. Also, this is how your browser can spot that your app is a progressive web app. When the app is opened by the browser, this is the first component that tells it, I'm a progressive web app, treat me as such. Second are the service workers. Service workers are the ones who do the heavy lifting in the progressive web apps and make them what they are. So in a regular app, user requests for something that goes to the web server, request is being processed, response is given back. Simple, right? In a progressive web app, the request first goes to the service worker. Service worker then checks whether that needs to be sent over to the network or not. If it does, sends it to the web server, takes back the response, processes it, and gives it back to the app. So in a way, it's a client-side network proxy. It executes, this is very important, it executes separately from the main browser thread in a separate thread. And this enables the app to receive messages even when the app is not open. The primary uses for service workers are they act as a caching agent and they handle push messaging. When they are not in use, they become idle and restart when they're needed. So, when a progressive web app is first opened, this would be a typical workflow. So, a page requests a resource that goes to the service worker. Since cache is empty, we send that request over to the network. Server gives us back the response, and at the same time caches it. So next time that page requests the same resource, step 2 can be completely skipped. So it will go page, service worker, cache, page again. This cuts on response time a lot and gives a great user experience for your app and enables it to work offline, of course. And of course, because there's a lot of opportunities for man-in-the-middle attacks between the service worker and the network, all of this goes through HTTPS. The lifestyle of the service worker goes through 3 steps. First is registration, second is installation, third is activation. First, registration tells the browser where your service worker is located and to start installing it in the background. So here, if we follow the code, first we check whether service workers are enabled in your browser. And if so, we tell the browser which file, in this case serviceworker.js, is our service worker and what will be its scope. By default, the scope of the service worker is the directory that it's in and all the directories below it. So this way your app, different parts of your app can be handled by different service workers. And of course, if you want to have only one service worker for your entire app, you place your service worker in the root of your app. After it's been successfully registered, next event is install. This event will trigger if the browser considers the service worker to either be new or for there to be a byte difference between this version and the previous version of the service worker. So this way, only one version of the service worker works at one time. This event is for each service worker filed only once, so it's a good time to do stuff like cache your API shell or your static assets. After it's been successfully installed, next phase is activation. Once it's activated, the service worker will control all the pages that are within its scope. And they maintain control as long as there are pages that are open that are using that service worker. So, for example, if there is a new version of the same service worker that is being installed, it will not take over until all of the pages that are still using the old version aren't being closed. And refreshing the pages won't do, because as I said before, service worker operate in a separate thread than the browser thread. So this ensures that only one version of the service worker operates at one time. So after all the pages that are using the old version are being closed, you can refresh your app, and this will activate the new service worker and allow it to take over. The activation event is a good time to clean up stale data or existing caches that you don't use anymore. Next up, push notifications. Why are push notifications so important for the web? It's because that's how you re-engage users. The web has a great problem with this, as opposed to native apps. Notification is a message that pops up on the user's device. I'm sure you've checked out a few while I've been speaking. They can occur in two ways. One is they are triggered locally by an open application. Number two, they are pushed from the server to the user when the app is not running. This way, you can re-engage the user to open the app again. They serve one key purpose: to help communicate to the users outside the app. How do they work? They are assembled using two APIs, the notification API and the push API. The notification API lets the app display system notifications, and the push API allows the service worker to handle push messages from a server even while the app is not running. And both of them are running on top of the service worker API. So how would this go? First step would be check if the push notifications are supported on your browser. Second, register the service worker. Third, request permission to send notifications. Third, generate a push subscription object and send the application to store it. After that, possibilities are endless. Engage with your users. So, if we go over this in code in a more practical example. First, as I said from definition, push notifications are built on top of the service worker API, so we need to check whether they are supported by the browser. Then we register the service worker, as we went over that. Third, we request permission to send notifications. Here, as you can see in this code example, we're checking if the permission equals to default. This means that the permission status is still in question. The app doesn't know whether the user has granted permission or not. So if the permission value is default, we fire the request permission method, and if and only if the user accepts, then we can send push notifications. Other two values for permission can be granted and denied. And that will look something like this, as you may already know. Next, we generate a push subscription object. So first, in this code, as you can see, an active service worker subscribes to the push server using the method subscribe, which returns a promise of push subscription. A push subscription object is contrived of two values. One is a public key, and the other one is the endpoint, which is the subscription URL. This object is stored in the database, and then when the server wants to send a push notification, it sends it to the endpoint URL. After the server sends it, the push server takes care of sending the push notification to the user. And you can check out that today is somebody's birthday. Next up, application shell structure. So, in a way to design a great progressive web app, you must separate what your static and what your dynamic content will be. If, for example, you had a news outlet for cat news, Static content will be menus, layout, outlet, logos, everything. This will enable the dynamic data to be displayed. So, for example, the news that the cats are the best. The application shell would be the bundle of code, if this were a native app, the bundle of code that you would publish to the App Store. By Google's definition, it's the minimal HTML, CSS, and JavaScript powering a user's interface. They need to load fast, be cached, and dynamically display content. Now that we've looked into all the technical aspects of progressive web apps, you may be wondering, did the web really need this? I mean, we have already enough solutions for things. I believe the answer is yes, and let me show you why. When we base comparison on the time spent on mobile web apps versus mobile web, native app users spend 18 times more time on mobile apps. But on the other hand, as you can see here, the mobile web has more than double the monthly unique visitors mobile apps have. So progressive web apps try to take best of both worlds. The time that is spent on it versus the way that it's easy to be reached to. In other words, it's much easier to make somebody click on a link than it is to make them install an app. Just as every technology, they have their pros and cons. But when are they better than native apps? When you have a small budget. One of the best advantages of progressive web apps is that development time is cut in half. You don't have to check out, you don't have to develop two solutions for two platforms. One works for every. Your time to market is crucial. When most of your user base has low-end phones and data limitations, these are apps that are usually targeted for developing countries. And it doesn't have to be developing countries as well. I recently uninstalled Facebook because I saw that with data and cache, it took 400 megabytes out of my storage, which is way too much. I mean, the Apollo 11 sent people to the moon with 4 kilobytes of RAM. When the users you are marketing your app to are not mostly iOS users. Last year, Apple started supporting progressive web apps, but there are still some issues with it, and for some companies, this may be a problem. So when progressive web apps launched in 2016, Safari did not support service workers, but in 2018, they, according to me, made a step in the right direction and started supporting it. There are still some issues with it, but they're being worked on, and I think they're making great progress. So, now that we've gone into how they're done and why they should be done, many companies were convinced that this will greatly help their business, and as you can see here, they were right. I picked here a few case studies. Pinterest had 40% increased time spent on site. The Uber app started working even faster in 2G, and Tinder's load time was cut in half. And I mean, for that means Pinterest, 44% increase in revenue of user-generated revenue. That's a lot. But I admit it is easy to increase your revenue when you already have a lot of revenue. In other words, it's easy to make money when you already have money. Progressive web apps have helped businesses that are not so well off as well. I present to you 2 case studies. First one is Flipkart Lite. I believe this was the first case study that was very successful for progressive web apps. Flipkart is India's largest, now I believe one of the largest e-commerce sites. And once they decided to switched to a Flipkart Lite solution. They saw 3 times more spent on site, 40% higher re-engagement rate, 70% greater conversion rate among those who arrive with the add to home screen prompt, and 3 times lower data usage. Jumia Travel. Jumia Travel provides a service for people who are traveling to the African continent. So again, just as India, a lot of users who have low-end phones. From 2016 and on, they developed a progressive web app solution, and they have had amazing results. 33% higher conversion rate, 50% lower bounce rate, 5 times less data used, 25 times less device storage required, which I think we can all agree is amazing. And they are not the only one. There are many companies that have had very successful transitions from native apps to progressive web apps. These are just some of the few. And if you want to know more about that, Google hosts an information resource and use forum, and they have a lot of case studies where they study these companies at great length. But now that I imagine, convinced you how awesome progressive web apps are, I think that in conclusion, I can say that I don't think that we should all just count native apps out, because even today, mobile app traffic is well over 50% of all mobile native app traffic is well over 50% of all mobile internet traffic. And many companies who already have solutions who are offered on many platforms will not feel a strong inertia to pursue a shift to web-based solutions. So whether progressive web apps will take over in the future or not is yet to be seen, but I think that one thing can be said for certain is that the market is increasingly embracing a hybrid model, a one that features both progressive web apps and native apps. Are there any questions?
Okay, there's still time to ask a couple of questions through our slido.com, so you can use it if you want. We got 2 questions so far. So like, first one was, how do progressive web apps work with content that is fetched from a third-party location or service?
I was working actually not too long ago with a progressive web app that it was reviewing cosmetic products, but the content for it was fetched from an API that was built from a separate site. So whatever it is that you would fetch from the website and cache in your app, you would, of course, need to be online. Just as to access a database, you will need to be online to access the API, get your results, store them in the cache. Next time you're offline, you can use them.
Thanks. And the next one was, how do you get around 5 megabyte local storage limit?
Well, this tricky one depends on what you're storing and what your app is. But generally speaking, I think that a lot of companies, for example, news outlets, have progressive web apps that if you store a certain amount of news until you reach 5 megabytes, that's a lot of news, then the user is able to scroll through everything that is being cached up until so far. So depending on what your solution are, some places you make cuts, some places you design it in a way that the user doesn't have to see something that has to be checked out online. So I think that most effective this is where you have to, design your app in a smart way.
So basically, we're not gonna get around it. We're just gonna adapt to the 5 megabyte, and yeah, okay.
But 5 megabytes for most apps is more than enough.
And we have one question: what does the landscape of progressive web app look like from frameworks standpoint?
Many as progressive web apps were introduced in 2016. Many frameworks first 2016, maybe even beginning of 2017, still not yet had, methods and frameworks to support it, but they have, to a large extent, formed communities that help them with that. So I believe, for example, React, if you're looking for a framework to develop a progressive web app in, React would be a great choice, because there's a lot of, for every framework, there has been a great community that has been created that can help you with everything.
No, I think I saw that most of the bigger frameworks have some support for PWAs.
I mean, there are endless JavaScript frameworks, so not all of them work as well, but bigger ones do.
So what do you see as possible hurdles to overcome that might negatively impact PWA future success?
I'm sorry, can you repeat the first part?
What do you see as possible hurdles, obstacles to overcome negatively impact the PWA future success? So like, what can impact negatively the success of PWAs?
Well, I think that the biggest hurdle that progressive web apps had was that Safari did not support them. They have started, but there are still some great problems with that, and still I think that's the biggest hurdle for them to overcome. Other that some device features that could be accessed with native apps, the web can't access. So depends on what your app is, you may have a problem with that.
Okay, we just have time for these two short questions. Can we cache images as well?
Yes.
And where do you see frameworks like Flutter in the future? So yeah, I like Flutter, so that's also interesting.
Oh, well, Marco likes Flutter, so I think that I will base my answer based on that. No, but I think that, as I said, most of the bigger frameworks have started supporting progressive web apps and creating developer communities as well. So I don't know how Flutter will fit ranking in here, but I see a bright future for them.
Yeah, I also agree. Like, Flutter can be very interesting, except for like Dart as a programming language, a little similar to TypeScript. But yeah, so yeah, we have one more. Yeah, we can do this. A technical question: does the service worker handle the caches? I think they do. Yeah. Does the service worker
handle the cache? Yes. So just for anybody who didn't get it, service worker checks whether the resource you requested for is in the cache. And if it's not, then sends the request to the network. Okay.
So thank you for all the questions. Thanks, Vedrana. Sorry for the technical problems. Give a round of applause for her. Thanks.
Thank you.